little chemistry quick hit here for effective nuclear charge. It is one of the things I see you getting wrong probably the most out of everything with periodic trends and how you use it. So effective nuclear charge, what it does is it talks about how strongly the nucleus of any particular atom is pulling in on its outside electrons or its valence electrons. And nuclear charge or effective nuclear charge is measured by the equation Z effective, as in like Z is the charge, is equal to Z, which is my number of protons, minus S, which is my number of core electrons. Now, if you remember, core electrons are the electrons that aren't the valence shell electrons. So what I'm going to do is I'm going to go over an example between lithium and fluorine, and hopefully this makes a little bit more sense. So if we talk about the radius of lithium versus fluorine, your intuition would tell you that because fluorine has more electrons, it should have a bigger radius, right? You're like, hey, I just got to jam more electrons in there, so it must be bigger. Wrong. If you think about the way that the electrons get added in, the first electrons in any element go into my 1s shell, and when the 1s shell is filled, they go into the 2s shell. So I've got my 2s here. So in the case of lithium, lithium only has 3 total electrons. I'm going to add my third electron into the 2s shell, and I'm going to have 1 electron in there. If we talk about fluorine, fluorine has 9 total electrons. We add the first electrons into my 1s shell, and then the next ones go into the 2s shell. So we've got both of our electrons going into the 2s shell. And in theory, when we start, these electrons are going into shells that are the same rough distance away. But what happens is, if you compare lithium, lithium only has 3 protons. Fluorine has 9 protons, and those 9 protons have a very strong pull on the electrons, pulling them toward that nucleus, and it actually shrinks the radius up. If you want to talk about this in terms of effective nuclear charge, we can do the calculation. So 3 is our number of protons minus our number of core electrons, that's 2. It gives me an effective nuclear charge of a positive 1. If I look at the case of fluorine, fluorine has 9 protons minus the same 2 core electrons because they both have their electrons in the 1s shell and they're filling up the 2s for their valence. Now fluorine has an effective nuclear charge of 7. And the greater the effective nuclear charge is, the more that that nucleus is pulling in on things. And so when we compare radii, lithium has a bigger atomic radius than fluorine because of its effective nuclear charge. Now, on the exam, the only time you are talking about effective nuclear charge is when you are comparing properties of things that are in the same period. And this is something that I see so many of you mixing up. So we only talk about effective nuclear charge as we are going across a period. If I am comparing, let's say, sulfur to chlorine or aluminum to phosphorus or any of those kinds of things. If that is the case and you are comparing properties side by side, bring in effective nuclear charge. If you are talking about elements that are in 2 different periods, effective nuclear charge is not going to be the argument you want to make. In that case, you want to talk about elements and the size of their electron shells or the number of their electron shells. But effective nuclear charge works really well when we are comparing things like radius. So if we are talking about the radius of phosphorus compared to chlorine. It also works really great if you are talking about ionization energies. It is harder to remove an electron from chlorine because chlorine has a higher effective nuclear charge than phosphorus. So chlorine has its electrons held in tighter than phosphorus does because it has more protons pulling in on electrons from the same shell. Hopefully that clears things up. If you have any other questions, come talk to me and meet.